we go. Joanna jogs along a straight path. So really, hey, in this class, that's how everything works. It's just always go back and forth, up and down. Nothing complicated. The time period is always worth noting. Her velocity is given by differentiable. It is sometimes helpful. So units are important. Okay, good. So I have a table of her velocity. Part A says, use data in the table to estimate the value of v prime of 16. So I have velocity, I'm trying to estimate v prime. So v prime is the instantaneous rate at which v is changing. The way you estimate an instantaneous rate is you find an average rate. I've been passing these out as fast as I can. If you haven't got one yet, please raise your hand. May not have one. This is for you to keep. This is the mother of all flashcards. So that's what Dr. Jason, please. This is calculus in one page, the entire year. So don't try to shrink it. I've already shrunk it about using a magnifying glass. So anyway, on this golden notes sheet, as I named it years ago, right here is a box on the front page that basically spells out what we want to do. We're going to approximate an instantaneous rate of change by calculating an average rate of change. We're trying to find v prime of 16. We're going to do that by finding the change in v divided by the time. Come back over here. And if you have this purple box written on your paper, you get 1 point. If you had gone one step further and worked out the computation, you get the point as well. But I would have just stopped right here. Please. Yeah, it's always best to include them just so we don't accidentally forget. But if you didn't include them, I think you're okay. They didn't specifically mention it, so. Anybody else? Troubles for Maddie, good question. Part B. Using correct units, explain the meaning of this in the context of the problem. Always stop at a period. Do that. So this is straight off the golden notes as well. Look on the front page, over here on the left. When you integrate the absolute value of the velocity, you're calculating the total distance traveled by, in this case, the person. So come back here. And what I'm looking for on my paper is this integral is the total distance. So keywords, you must say total distance. You don't have to say Joanna jogs. You can say she travels, or you can just say the total distance traveled. I think they'd still give it to you. You do have to say in meters. And you do have to say over the time interval 0 to 40, you have to say the word minutes. If you did that, you get 1 point. Please.
Instead of total distance, I said meters.
Just read it to me.
I said that integral means you're finding the amount of meters you are on the job in the time period 0 to 40.
I think you're fine on that one. Yeah, good question. Oh, so the reason they won't give you the point is because of the unit error. You said it was the total distance measured in meters per minute. So the distance would just be meters. So because of that error on the units, they won't give it to you. That was a good question. That makes sense, right? Yeah. Good question. Brandon.
So for the approximation, what kind of select it as absolute value, and then 12 times 200, 8 times 240, minus 4 times 220, 18 times.
Obviously, explanation. Yeah, this is probably okay. You got Yeah, that one's fine. You don't have to take it. No, you're yeah. I think they'll give it to you, but you need to be looking careful. It's only the process is the absolute value. So you only want the absolute value around the. The second, third point comes from having what I boxed in red. Jackson, go ahead.
I have, so I'll just try to explain. Okay, so in the equation,
Yeah, no one talk.
I put the 4 multiplied by, and then in parentheses, I put negative 220. Since it's total like distance, so it's absolute value sign, does it matter if it shows the negative sign, or does it want to be positive like it is up there?
So you actually showed a negative sign.
Yeah.
Yeah, they won't give it to you.
Okay.
Because, good question, 2 pebbles. Hey, you're integrating absolute value of velocity, so you have to take the absolute value of the velocity.
Okay.
So that, look, 2 ways you could get the point. You either got to have it written as I'm showing, where you, in your head, you said, hey, the absolute value of negative 220 is a positive 220. Or you could have done this. You could have said, hey, let's put absolute value bars around each of these velocities. You shouldn't put it around the time. We're not taking the absolute value of the time. But you could have done that as well. That would be legal. And they'd give you the point for that. There you go. Please.
What if you only did it over the 240?
Oh, that would be fine as well. So like you've got 200, 240, absolute value, negative 220, and then 150. They'll give you that. That's fine. Doubles for Erica. There you go. Oh, please. Yeah, that one I'm not sure. I've seen a couple of people have that. Look. So a couple of people put the bars around both the time and the velocity, which is actually wrong. You shouldn't be absolute valuing the time. dt doesn't have absolute value around it. Mathematically, it does give the exact same result because dt is always a positive number. So they might give you both of them. They might only give you one of them. I think they probably give you at least one or two.
But it is okay to have absolute value like around the whole thing.
I'll say it back to you. It really is not correct.
I mean, like around, not just.
Oh, like you did like this.
Yeah.
That's also not correct. What's being absolute valued is just the velocity. Like we don't. It's not the whole integral being absolute valued. It's just the velocity. So whether you get, okay, my best call really is that I said they'd give it to you. I really think, on second thought, that at most you're going to get one of the two. Because the grader's going to look at that and say the person's mixed up. You're not supposed to be absolute valuing all of it. You're not supposed to be putting absolute value around dt. It's just the velocity.
So if you get 0 of 3 or just 1 of 3?
1 of 3. Anybody else? Cool, next one. Okay, part C says, Bob is riding his bicycle along the same path, so a different person now. Different time period. This is why you need to read carefully, not rapidly. Bob's velocity is modeled by this equation. Okay. Find his acceleration. So because this is Bob's velocity, to find Bob's acceleration, I need to find the derivative of b, and then plug in a time value of 5. So if you have b prime of t written down as I boxed, you get 1 point. If you properly plugged in the 5, you get another point. You do not have to work this out. I wouldn't. I just stop there. Questions on this one? Please.
It's okay to change the A to right instead of B prime.
I think they'd be okay with that. There you go. Next one. based on the model from part C, so based on this, find Bob's average velocity for this time period. So on your golden notes, right in the center of the front page, it says the average value of a function is always found by integrating what you're trying to find the average of, and then multiplying by 1 over the width of the time period over which you're averaging. So I go back here, and that's what I'm going to do. So my first thing I write down is the integral I need to find the average. So this is worth 1 point if you have this purple box exactly as shown on your paper. Make sure you have these parentheses. Without those parentheses, it's wrong. So, there you go. Please, Ethan.
What if I wrote that, but I plugged in 5?
So like you wrote all this, you put a 5
Yeah.
in for all the T's?
Yeah.
They won't give you that point.
Okay.
Yeah, it's not right. You're supposed to be, but this one has nothing to do with 5, so.
Yeah, I don't know what that is.
Yeah, you just probably read too fast. It's okay.
If you just wrote a B of T in the middle,
That's okay. Absolutely. Yeah, you write 1 over 10, integral from 0 to 10, B of T dt. Totally fine.
So would it be okay if we put, instead of having parentheses, we had absolute value bias because instead of an absolute value.
No, they won't give you credit for that. That would be 0. Because we're not finding the average. See, the absolute value, okay, look, you're mixing up the following. Look here. Here's what you're mixing up. I need to find the total distance, then I would have had the integral of the absolute value. If I needed to find the speed, speed is the absolute value velocity. So if I make an integral like this, and I put absolute value here, I'm not finding the average velocity, I'm finding the average speed. So hey, every eyes on me, everybody. That could easily come up on an AP question. Find the average speed. It would look exactly like this, but instead of integrating velocity, you integrate speed. Speed is the absolute value of the velocity, so you have just absolute value marks. That'd be a different question, but it could come up. Other questions? Jim?
The last part where it says
Yes, I miswrote that. Thank you. Pebbles for that. So this should have been 300 here. The second point is if you correctly find the antiderivative. So the antiderivative of t cubed over 3 is t to the 4th over 4. This antiderivative would have been, let's see, 6 is a multiplying constant, then t cubed over 3, and then I just divided to get 2, but if you left it like this, that's totally fine. And then 300t is the antiderivative of 300. You must have the bar. You've got to indicate that we're evaluating from 0 to 10 there. Please, Jen.
So with that that's in green, I had that correct, and then when I went to the brown, instead of keeping the 2 parentheses 10 to the third, for some reason I wrote to the second, but before I had it to the third.
Gotcha. So this box is perfect.
That box is perfect.
They'll probably take off the 1 point. They used to have 3. If there is some chance, Hannah, that they'll kind of look at everything else and go, well, everything else is perfect, so they might let it slide. But as we're practicing, I think it's better to just keep pushing yourself to get a little bit better. So, question? 2 questions, Sarah?
Can you go over why at the very beginning you used
No one talk. I can't hear. Say it again.
Can you go over why at the very beginning you used
Let me ask you, and I think it will click. If it doesn't, keep talking. So what does the equation for B of t represent? This velocity, very good. And what would the symbol B prime represent? Is acceleration. And what are they asking you to calculate?
the average velocity?
So to find the average velocity, I want to integrate the velocity. like whenever you're finding the average of anything, you always integrate what you're averaging. That's really the answer. So if we had integrated b prime, we'd be finding the average acceleration. I don't know if that helps. Okay. Oh, please.
How do you know when to do the anti-derivative and when it's rule number 17 where you do the top of the interval minus the
Right.
bottom?
Was I helping last night? Forgot, it's not right there. Oh well. Anyway, keep that. Grace, yes, that's what it was. She had the exact same question. Thank you. So here's how I would think of it, Brenna. If you read a problem and something in the reading indicates that you should be finding the derivative of the integral, like in somehow the wording or the symbology of the problem says, find the derivative of the integral, then you're using Rule 17. That's less common. More common is that you are simply presented with an integral, like this, and we need to find the value of that integral. Our first choice would be to just pick up our calculator. But since we can't do that, they're not asking us to do a Riemann sum, and there's no graph, so we can't find the integral with area, we have to use the antiderivative method. The only other time I would use Rule 17 is if I was completely stuck, couldn't think of anything else to do, then I sometimes use that rule and it does help. Right here is what I'm thinking on the golden notes. And Brenna, that one causes people problems. So every time that question comes to mind, ask it again. Like anytime we're in a problem, if we are still not sure, just ask it again. I keep pointing to, okay, this is the reason why we did the antiderivative. This is the reason why we did the derivative, Rule 17. Then it will stick. So don't hesitate to ask again. Right here. Throughout the AP test, you have to find the value of integrals on lots of different problems. We've done it twice on this FRQ already. Like right here, if you look back, in part B, we had to find the value of an integral. So like right here, they didn't tell us to find the derivative of this integral, we just need to find the integral. Now we didn't do it the antiderivative way because they said Riemann sum. But back here on the golden notes, notice, front page, it says to find the value of an integral, your first choice is calculate. Second choice is really depends on what they give you. If they give me a graph, then I could possibly use the area method. If they say do a Riemann sum, I can do that. Otherwise, I'm using the antiderivative or fundamental theorem method. So, and that's what we had to do in part B. Other questions, please.
You have given enough the average velocity. I found it out. You have enough to people to think I'm 15.
Let me double check the answer. You don't have to go that far. So this would be wrong if you have the absolute right part. This would be right. Now if that comes out right, it's point. I don't know what that is. So yeah, you get that point. Well, parentheses are fine. Parentheses and bracket mean the same thing. Absolutely. In fact, I've actually never seen this notation before. That was new to me. Like I always use the parentheses and the bar. Apparently that's okay too. Anybody else? Please. Okay. So Rule 17, the way I think you should think of it is, if you look at your golden nose, and you look at the left side of the front page, down that left side is the list of all the different derivative rules we've used. And towards the bottom is the jokingly named Rule 17. I should have counted and then put a 17 right there. Probably the count, but anyway. It's simply, like right here, if I need to take the derivative of the inverse sine, I use this rule. If I need to take the derivative of the tangent, I use this rule. If I need to take the derivative of an integral, I use this rule. And the rule is really simple. Like up here, you know, if you're taking the derivative of the tangent, you're like, oh, it's the same as 1 over the cosine squared of whatever. Well, here you just grab whatever function's listed, and instead of using the variable of the function, you plug in the upper limit. And then you multiply by the derivative of the upper limit. Make sure this is dx because that's dx. And then subtract the same thing with the lower limit. That's all. There you go. Okay, I already made a video of 4, and I didn't really think we got time this morning. 4 is a different problem, but you'll use the video to grade that one. If we have time, we'll go back and do questions on 4.